Good morning. Dear representative of the Bern municipality, dear members of the Swiss Academy, dear members of the Balzan Foundation, thank you for welcoming me in the town of Bern to give this lecture. Thank you for the prize, of course. I'm very honored and very happy to be here. And thank you to Nathalie for this very nice introduction. Strangely, the program is built up in such a way that I'm going to take you to the stage before what Eske Willerslev just explained. So we're going to move back in time to see what happened before. So I'm going to present you the previous episode of this story of human evolution. If there is one thing I would like you to remember from my talk, I give it right now, is that when we're talking about human evolution, it's very difficult to disentangle culture and biology. And so after hearing Eske, after hearing me, you'll see that paleoanthropology is all about the interaction between culture and biology. And so I would say it's difficult to separate the part of human and social sciences from the part of natural history, I would say. And all my career, I've been sort of torn between these two fields. Today, there is only one species of humans on Earth. And I think this is what probably looks to you the normal situation. You know, there are humans, and these humans have been able to colonize all the planet. They live even in the most extreme environments thanks to their technical adaptation, but also because of their cultural complexity. I mean, humans are able to build up network of people who are connected over very large distances. And Eske touched a little bit upon this subject. Maybe we can come back to this issue in the discussion. So this situation that looks normal, in fact, is not normal. It prevailed only. It has prevailed only for, I would say, 40,000 years. Which is nothing compared to the million years of hominid evolution. If you move back in time, the situation is completely different. So this tree shows you only the last million year of hominin evolution. And what you see is that there are many lines of evolution, not just with the members of our species, which are here. I hope you see something. No, you don't see anything. But you see that there are also other branches in this tree, and all these branches disappeared about 50 or 40,000 years ago, and only this orange bar is coming to the present. So you see on the left of this picture, the Neanderthals, the Denisovans, which are sort of sister groups of our species, and all these blue lines are species of hominins with smaller brains that lived, for example, in Asia. Some of these species were very different from us, and so we recognize them as different species of humans. For example, on the right, you have a reconstruction of a small hominins that lived in the Indonesian islands only 50,000 years ago. And you see this little creature is very, very different from a modern human. What's really probably most striking when we look at this evolution is the speed of divergence of all these lineages. On the right, you have the skulls of two different species of chimpanzees who diverged about 2 million years ago. I don't know how many people in the audience are able to say what is the difference between these two skulls, but believe me, it's very difficult to find a difference. 2 million years of divergence. On the left side, you have a Neanderthal and an Homo sapiens that lived in Europe a couple of 10,000 years ago, and only after something like 600,000 years of divergence, you see the huge difference in terms of phenotype. Even kids from a primary school are able to see the difference between these groups. In terms of geography, what does that mean? Well, we have in Africa the ancestors of our species, while in Eurasia, for a very long time, we had the development of these large brain hominins like the Denisovans in Asia and the Neanderthals in Western Eurasia and Central Eurasia. And what happened in the last, let's say, 100,000 years is an expansion of our species out of Africa and a replacement of all these other archaic hominins with a partial absorption of them. And also, as Eske showed, this new species was able to colonize lands where there was never hominins before, like Australia, like the northern latitude of Eurasia, and like the Americas. So this notion that we have an African origin comes from paleontological evidence. We have some fossils in Africa that looks like extant humans. But in the 80s, 90s of the 20th century, it was largely the genetic evidence that basically proved this African origin. What you have on this slide is a tree showing you the branching of what geneticists call mitochondrial DNA, and it's a part of our genome that is only transmitted by the females to their descendants. And this part of the genome is not recombined at each reproduction. And so it's a kind of easy way to basically decipher lineages of present-day population. And what you see is all these lineages that are highlighted in green are African lineages. And what's quite clear is that all the non-African humans come from one branch of one African lineage, haplotype lineage that we call L3. And so it's a sort of, if you imagine a tree growing in a garden, Africa, there is one branch going over the wall of the neighbor and expanding in the next garden. And this is what non-African people are. And for a long time, largely because of genetic evidence, we believe that this tree had been growing in East Africa. In the years between 2010 and 2017, we have been conducting work in North Africa, in Morocco, very far away from East Africa. And we found there actually the oldest representatives of our species. And this discovery, of course, led the community to revisit all this model of origin for our species, not only in terms of geography, but also in terms of the process of emergence of what we call modern humans or modern Homo sapiens, people like us. Because these people from Jebel Irhoud, who lived in Northwest Africa 300,000 years ago, can be connected to us by some features. For example, the face of this human is the face of somebody you could meet today in Paris, in the metro, you know, and it would not look, you know, so surprising somehow. But if you look at other features, you see much more archaic traits in this early Homo sapiens, and this is particularly true for the brain. Unfortunately, we don't have fossil brains, but we have the box of the brain, the shape of the brain, and also how this shape changed through the development. And without entering too many details, what you see on these charts is that when you move from Homo erectus to Neanderthals and other large brain hominins, what's going on in terms of change in shape is mostly an increase of the size, without much reorganization of the brain. And this is connected to more complexity in the behaviors, probably also more social complexity, not just technical. The problem with this increase of the brain is that the brain is a very costly organ. It costs a lot in terms of energy. And so there are limitations in terms of how much energy you can extract from the environment to fuel your brain. And what's been going on with our species, which is shown in these polygons, blue, violet polygons, is that at some point from the stage of Jebel Irhoud, starting from a rather primitive shape, we stopped somehow increasing the size of the brain. We started reorganizing the brain in terms of structure. For example, we see this very strong development of the cerebellum, and we suspect that a lot of mutations occur at the same time, let's say in the last 300,000 years in Africa. And all these changes, all this reorganization are probably connected with some cognitive changes. At Jebel Irhoud, we find not only the oldest Homo sapiens, we also find the oldest form of what the archaeologists called Middle Stone Age in Africa. And Middle Stone Age is a big technical innovation, is making stone tools from flakes that are retouched and not using any more large cutting tools like bifaces that are used by Acheulean people before. And when we look at the dispersion of this Middle Stone Age in Africa, we see that after 300,000 years, we find it a little bit everywhere where we have archaeological sites. So, of course, a large portion of Africa is still to be explored, but in North Africa, in East Africa, in South Africa, we have a lot of this Middle Stone Age. We suspect that this development of the Middle Stone Age is directly connected with the development of our species of Homo sapiens. Why are we so interested in this Middle Stone Age? Because it's among the Middle Stone Age assemblages that we see, after 150,000 years ago, a lot of complexity developing. First of all, in terms of diversification, we sort of, on the map, we sort of see different cultural areas developing in area with their own style in making objects. And we also see the development of a lot of objects that have a symbolic value. So in other words, there are non-utilitarian objects. There are things like beads, like pigments, like carved objects, and we think they are related to an increase of this cultural complexity and this ability of humans to build up networks and to exchange between all these networks. So how, when, and why these humans were evolving in Africa, developing all these things, having this new brain, started to expand it out of Africa into Eurasia to replace Neanderthals. Initially, we think it's mostly for environmental reasons. If you look at the geology of Africa, you see that during the last 500,000 years, you have periodically episodes of what we call the Green Sahara. And these episodes of Green Sahara corresponds to moments when the summer mousson coming from the Gulf of Guinea goes much higher in latitude than usually. So it goes beyond the Sahel. And what you have during this episode is that the Sahel and the Maghreb merge. And so the Sahara disappears. You have a landscape of savanna with rivers, with lakes. Some of these lakes are huge. One of these big lakes on the map is bigger than Germany, so it's serious. And of course, humans that were exploiting this kind of environment, they spread with these savannas and they occupy the Sahara. We have a number of these Green Sahara episodes lasting between something like 5,000 years and 15,000 years for some. You see, they are represented here by these green bars over the last 500,000 years. And the point is that this phenomenon does not affect just Sahara, but in fact it affects all the deserts that are between the Persian Gulf and the Atlantic. And in the Near East, in Arabia, for example, you have also green Arabia episode at the same time. And so, sort of naturally, humans expanding in this kind of environment has been leaving Africa without knowing they were leaving Africa. You know, nobody told them, hey, you're entering Eurasia, but they spread it into this southwestern part of Asia. We have evidence of that, both from paleogenetics and from paleontology. So on the side of paleogenetics, we have discovered recently that sometime around 300,000 years ago, 250,000 years ago, there is an integration of this mitochondrial DNA, the one transmitted only by the females, from the African genome into the genome of some Neanderthals, and then it spread into Eurasia. And even more recently, it has been found that the same phenomenon occurred with the Y chromosome that is transmitted only from the males. And this is something we see in fact, in many other species of mammals in the same time period. Like, for example, bears, we see this integration of DNA from one species to another in relation with climatic fluctuations. We also have fossils. This is one of them, something which is clearly a non-Neanderthal maxilla that has been found in Israel and is dated about 180,000 years ago. But all these early expansions of sapiens out of Africa seem to have been rather limited to Southwest Asia, maybe south of Asia, but certainly not the higher latitude of Eurasia. And it's only after 50,000 years ago that you start finding our species in the domain of the Neanderthals and the Denisovans further higher in latitude. One of the first specimens that has been documenting this expansion is this femur coming from Western Siberia, 57 degrees of northern latitude. And so it's really an African that went very high in latitude. Unfortunately, this fossil has been found out of any archaeological context. So we know that about 45,000 years ago, there were people like that in Eurasia. And one of the headaches of the archaeologists and paleoanthropologists has been to connect the cultural evidence with the biological evidence of this expansion. On the side of archaeologists, suspected that this expansion of our species was connected with something we call initial Upper Paleolithic. It's a certain style of stone tools that we find in the Near East. We excavated, for example, a site in the Negev desert called Boker Tartit, where you find this kind of assemblages. And then it's spread higher in latitude between Eastern Europe and as far as the Altai and Mongolia in Asia. So in this band of latitude, probably we have something like early Homo sapiens. So of course, like many, I've been struggling to try to find some fossil evidence of that. And for that, we have been conducted works in a site called Bachokiro in Bulgaria. All these sites that we have in Western Eurasia in this time period are rather disappointing because we don't have fossil hominins. We have a lot of archaeology, but we don't have bones. We cannot say who made what. Was this made by Neanderthals or by Homo sapiens is difficult to say. To resolve that, what I started doing is using a technique called zooarchaeology by mass spectrometry, which is basically using the collagen contained in the bones to identify through mass spectrometry to what kind of species these fragments of bones could have belonged. And this allows us to treat thousands of tiny pieces of bones which have no morphology, or it's impossible to say what they are. But by using this molecular technique, it's possible to identify list of species presented in archaeological sites, even when there is nothing very spectacular. And from time to time, here in this list, we have 1%. 1% of these tiny fragments of bones are humans. And this is fantastic because these tiny fragments, we can date them directly. For example, here at this site of Bachokiro, we have been able to identify specimens that are more than 44,000 years ago, so very old for the time where this was published as early modern humans in Europe. And we also can extract DNA, not ourselves, but colleagues like Eske or others. And this tells us a lot about these people. In particular, these people in Bachokiro, we see that they were in contact with Neanderthals, and that they interbred locally with Neanderthals only 4 or 5 generations before the time period where they lived. We also can learn a lot about the environment of these people by using geochemistry. And what we see is that this early peopling of Eurasia, Western Eurasia by Homo sapiens, did not occur during warmer periods. So now the environment is not something that is an engine for this movement. In fact, they lived in environments in Bulgaria, for example, similar to the environment of northern Scandinavia today. And so it's really, I would say, culture that drives this expansion, and probably the difference in terms of social complexity, this networking we've been talking about, and also, of course, some technical improvements that allowed the replacement of Neanderthals by these early modern humans. So we're continuing this work with a lot of these lithic assemblages that we find in Western Eurasia. All these color spots that you see on the map of Europe are different, what archaeologists call techno-complex. They don't dare to say cultures, but let's say probably some kind of ethno-linguistic entities. And we're in the progress by using these molecular techniques I described to decipher the makers of all these assemblages. One very, I would say, striking aspect of all this process is that we see that we don't only have genetic exchanges between these groups, but we also see how innovation in the behavior pass from one group to another. And for example, these non-utilitarian objects that I described in Africa, we see them coming in Europe. On the left side, you have pendants made of bear teeth from Bachokiro. And a couple of millennia later, or centuries later, we see the same thing developing among the latest Neanderthals in Western Eurasia. So it's very likely that we have a sort of acculturation accompanying a mixing of population during this whole process. Well, I let you now with all these conclusions, and of course I would like Eske, acknowledge the many people who have been working with me over the years, and in particular the young scientists, the PhD students, the postdocs. It's difficult to name, I mean, as you see on this picture, there are many, difficult to give names, but it's wonderful to have been able to support them and to build up a network of them and continue to work with them like good modern Homo sapiens. Thank you.